part 284A7, line 22f1fa19a7. Jupiter Jovian Thermosphere Ionosphere Pioneer 10 ARECIBO Wow Seti. There's the Wow Seti alien radio signal. And here's Jupiter's thermosphere and ionosphere from www.lpl.arizona.edu. It's a PDF from RV Yell. Important on Jupiter that they are on Earth. Finally, H plus in the Jovian ionosphere does not react readily with H2, leading to large densities of this long-lived blah blah blah. And it's from google.ca. So July 17th, my thoughts. Keyword Jovian is Jupiter's ionosphere where Pioneer 10 has measurements of the electron density distribution in 1974. Data quotes wiki. Okay, so we're going to go to the data quotes. We're going to look at some pictures here. There's Jupiter, and there's a little satellite that flew around there back in 1972. Mission was from 1972 to 2003. 30 years, 10 months, 22 days, and then they lost communication. Jupiter flyby back in 1974. An interstellar mission, 1997. I think the interstellar mission is when they actually landed on Jupiter and got some samples. From what I can gather, I'm not sure if I'm right or wrong, okay? Just thought it was interesting. Pioneer 10 in the final stages of construction. This is back in the 70s, of course. We've come a long way. Look how big that thing is compared to what we make now, little things. This is kind of the ARECIBO plaque there. I didn't know what it was at first, and then I figured out. So this says imaging photopolarimeter, Geiger tube telescope, meteoroid detector sensor panel. That's these things here. Helium vector magnetometer, main antenna, plasma analyzer, trapped radiation detector, cosmic ray telescope, infrared, radiometer, charged particle instrument, ultraviolet photometer, asteroid meteoroid detector sensor, and radioscope, thermoelectric generator, and of course there's a plaque on this satellite showing humans. Pioneer 10 and Pioneer 11 spacecraft diagram. So these are the components of some of the little gadgets that they added to this thing that was used for testing. So this instrument measures the fine structure of the interplanetary magnetic field, maps the Jovian magnetic field, and provides magnetic field measurements to evaluate solar wind interaction with Jupiter. The magnetometer consists of a helium filled cell mounted on a 6.6 M boom to partly isolate the instrument from the spacecraft's magnetic field. And that's from Edward Smith. Quadaspherical plasma analyzer. Peers through a hole in the large dish-shaped antenna to detect particles of the solar wind originating from the sun. Principal investigator was Aaron Barnes from the NASA Ames Research Center. Charged particle instrument, CPI. Looks like a huge old camera. Detects cosmic rays in the solar system. Principal investigator was John Simpson, University of Chicago. Cosmic ray telescope. Collects data on the composition of the cosmic ray particles and their energy ranges. The investigator was Frank McDonald from the NASA Guarded Space Flight Center. Geiger tube telescope, GTT. Surveys the intensities, energy spectra, and angular distributions of electrons and protons along the spacecraft's path through the radiation belts of Jupiter. And the principal investigator was James Van Allen. Ultraviolet photometer. Ultraviolet light is sensed to determine the quantities of hydrogen and helium in space and on Jupiter. The investigator was Darrell Judge. There's the Pioneer plaque. This is the ARECIBO message, part of it. And this was it's like a brass plaque, I think, that they stuck onto this satellite. So if anybody found this satellite, they could look at this and they would know what it means. See, there's the sun, and then it shows Earth. And it shows the little satellite thing is from this Earth here. It's pretty simple. At least they didn't draw a stickman, eh? Pioneer 10 interplanetary trajectory. So there's the route that it took. So this is the Jupiter orbit here. So you have Jupiter at the encounter. Planet experiments were done on this side. Pioneer heliocentric trajectory, escape from solar system. Jupiter at launch. Then it's got your second mid-course correction, 30 days. First mid-course correction, 4 days. I don't know what that means. Near-Earth experiments, initial orientation, Earth, liftoff and enter Earth's shadow, Earth at encounter, and I guess this is the Sun. Okay. Pretty solid. Pioneer 10 trajectory through the Jovian system. So here it is here. There's Jupiter. There's the low moon and Europa moon that circle Jupiter. They orbit around it. Ganymede is the bigger moon. It circles around Jupiter. And then you have the Earth and the Sun to the right. Okay? So that's the end of that video.